All right, it's 17:20, as in time for the almost last session. I'm Thomas, and you can't see my slide over there, but someone will probably fix that in a bit. I can see it over there, but I can't see it over there. Oh, now I can see it. Perfect. So I'm Thomas. I am a developer, and I'm going to talk a bit about testability and what is testability. And questions should be sent to Slido, as you probably know by now. And let's start with who am I and what makes me qualified to be here. Well, I am a developer and I'm test infected. Been that for a long time. I did write my first program 1982 or maybe 83. I'm not sure. I was 15 years old and I wrote a database because there was a need for it. I have written code that tests other code. First time was in August 98. I had no idea what I was doing and thought it was a fun idea, although it was perhaps not a good idea because we were rather stressed in the project back then. I have a master's degree in computer science. I'm the one with the highest degree in my family, which is not very much because I only have a brother and he has almost a master in chemistry. I've been a consultant for some time and I run my own company since 10 years back, a little bit more than 10 years actually. And today I'm only going to talk about functional testing. So if you're thinking about anything else, don't. Unit tests, integration tests, acceptance tests, yes, absolutely not. Load testing or security. That's important, but not today. So, testability, what does that mean? Well, there are four main things that you want to consider here. Accessibility, how can we even reach the thing we want to test? Can we reach it? Observability, how can we see a change? Can we see a change? If we can't, then we can probably not even test it because we have no idea what happened. Predictability, how do we know what should happen? There are a lot of cases where this is obvious and there are cases where it isn't obvious. Reproducibility, how hard is it to actually do this again? If we can't do it again, it's really hard to rely on this. First question is, of course, is everything testable? And I would say yes, if it does something. If we can observe a change, then it is testable. It might not be easy, but it is testable. However, everything is obviously not created equal, and some stuff is easy to test and some stuff is hard to test. So this is two different methods that actually happens to live in the same class next to each other. I wrote both of them. The one to the left is actually seriously hard to test because you have to fire up a context, you have to get stuff connected, and then you would run something and you would have to check a result in a database. The other one is a pure function that pretty much creates the SQL I want. And this is a way to mitigate a behavior in the Oracle database where you can't have more than 1,000 items in an in clause, which is a pain if you have more than that. Broken glass syndrome. Anyone heard of it? If something is a little bit broken, it's and we accept that, then it's just going to break more. So if you think about your continuous integration, if you allow build to fail, soon there will be more failures, and that won't be very good at all. And this comes from an observation back in the early 80s or late 70s, I'm not really sure, where it was observed that if you leave, if you have an abandoned building, someone breaks a window, and if you fix that window immediately, everything will be good. If you don't, every window will be smashed within a week. So if you allow something to break, then it's going to slip, and all of a sudden everything will be broken. So we don't want that. Right, accessibility. How do we even reach the thing that we want to test? Well, it's a matter of distance. And what do I mean by distance? Sometimes things are easy to test and sometimes they're hard to test. And here's an example. This is a controller from a Spring Boot controller that I've been using in another presentation a few times. It is both. It is hard to test because the distance to test it is really far, and it's also very easy to test. And with distance, I mean how much setup do I really need to do before I can test things. So in order to test this, let's say basic functionality, basic correctness, all I have to do is write a unit test called the public method. Maybe check for a side effect in this particular case, but I don't have to do anything else. However, if I want to test that I have succeeded in all the annotations here, then that's a different thing. Now I need to fire up a context. Now I need to fire up Spring Boot. I need to have a HTTP client that actually sends a request in order to be able to see that this endpoint exists, and in order to see that the result is sent back properly. And in this case, I was expected a 201 created. So the distance here is very different. And from just a basic correctness point of view, this is really easy to test. If I want to verify that I've actually managed to get all the annotations correct, then it's actually a lot of work. So distance matters a lot. I recently seen questions on the internet. How do I test private functions? You don't. Stop. You don't. They are private for a reason. And this is an example. This one could perhaps be tested because it returns something. It seems to be a pure function, but it's private, so it shouldn't be tested. Don't even try. If you have to, for some reason, then there's an escape hatch, of course. Make it package private. It's possible now to test. Is it a good idea or bad idea? That's up to you to judge, but sometimes I think it is a good idea. Sometimes I think it's a bad idea. I have one example where I have a parser where I can parse tiny bits of some source, and there I have a lot of these package private things because I can feed it, in this case, a JSON, and it's not that much that is needed, and I can verify that my parser is actually working. So sometimes it's good, sometimes it's not. Observability. We should be able to see a change. Well, what do you have to do to see it? Well, if I have a method, perfect. We could just look at the return statement and see, is it what we expected or not? Easy. Sometimes that's not possible, so you have to look in some other way, a side effect. And the common case is, of course, that you store something in a database. How do you know that it was stored? Well, you have to check that somehow. And the way I tend to do that is check first and check after. And now it should be there. The first time it shouldn't be, and next time it should be. Not that very hard, but it's a side effect. And sometimes you have to do that. As I said, pure functions, easy. This guy, which is production code, it's not, but almost. I removed some words so you shouldn't be able to see too much details. Rather easy to test. Right. Predictability. How can we predict if this will work or not? That's complicated, and we have some enemies here. We have time. If time is involved in whatever you are testing, it's a pain because time moves on. Now we have to take that into consideration. Even worse sometimes could be randomness. It doesn't behave as we want it to behave. It's very random. So if you have to take that into consideration, you may have a problem. Databases, almost everyone, I suppose, is working with databases. And if you have a shared database, which I unfortunately have in one context, then this is all of a sudden it gets complicated, because now something else can break this database. Sometimes you have an external service which may or may not work, and if you are unlucky, you might even be in the situation where you can't even compile without it working. I've never been in that situation myself, but I do have colleagues that have been there, and let's say that they weren't too happy. How do we mitigate this then? Well, there is a very simple yet powerful idea. The fundamental theorem of software engineering. Look it up on Wikipedia if you want to. It's a very bold statement. And we can solve any problem by introducing an extra level of indirection, or another level of abstraction if you want to. And this is a claim that the guy called Wheeler, David Wheeler, came up with, and this is back in the, I'm not sure if it's 50s or 60s, but it's a long time ago. Most of us were probably not even born back then. So what does he mean by that? Well, if we want to mitigate things like time or random, or database, or external service, hide it behind something that you can manipulate. So wrap it into something. And make sure that you get a well-known value out of that thing. And then you're set. An extra level of indirection. So this is an example where something is really hard to test. We want to simulate something. And the simulation is rather boring. And that's because I'm not interested in creating some kind of complicated math because of this. What I want to look at is how can I cope with randomness. This is an implementation that is kind of reasonable. We have a simulation and we get the random number from somewhere. However, this is not testable, except that you can get 100% test coverage from it. Very easy. Just make sure that you run it through a test runner. And I asserted that there is something that comes out of this. I have no idea what. As long as it is in between a certain interval, I was happy. But it's rather useless, and it won't help me. So how do we solve that? Well, this is almost the same thing, with one difference. We don't call get age immediately. We call it on something that is injected here. So the complete implementation could look like this. So we have a private field that we set, which implements get age. Now, if we want to, I can stub this. I can trivially create two implementations of this. One that will return a well-known value, and one that will return randomness. Now I can test this, because as long as I have a well-known value, I know what I should get. I can calculate that. So the test that actually check this would be this test. I inject something that I call well-known age, as age, and then I know what I should get. And well-known age is implemented like this. Trivial. But not obvious. Not obvious for everyone all the time. And if you're wondering, 42 is the answer, if you have read the Hitchhiker's Guide to the Galaxy. The production code could look like this. We still have the simulate thing. And I just moved the get age randomness somewhere else. So if I inject this thing called random age, then I'm set. I know that this will actually probably work, or maybe. So, in the abstract promise of war story, and of course, I had to call my good friend Johan Pütz to check this. So this is back in 2001. This is before 9/11. Amtrak was a thing. People were running around in Florida, where he was, with white overalls and really stressed out. He was there to write his master thesis, and I don't even know what it was he wrote about, but it's some kind of simulation, including economical scenarios, including a lot of different things, stock exchange rates and stuff. So we have two problems here. It's a complicated mathematical problem. The only reason why he was writing a master thesis about it. And he had random parameters inside his C++ program. What a joy. Because this meant that every time that he had done one execution, he had to spend hours double-checking, was it right or wrong? So now when he knew the parameters, he could do the calculation manually and then deduct, is this correct or incorrect? It spelled disaster. From the perspective that it's really slow and cumbersome. However, he did manage, so he got his degree, and I guess everyone is happy. And had I known about this back then of course I could have helped him out. But now I remember we had a lot of chatting over ICQ. You might remember it or might not. And it was, yeah, he was frustrated, and I couldn't even help him. That was horrible. Today we have both learned how to do this. You have to know the input values and the expected result, of course, which is another thing he just mentioned when I called him and talked about this. Right, external dependencies, and perhaps even expenses, those dependencies. Say that we have a payment gateway or a database. How do we interact with it? Well, it's solved. We just add another level of indirection here. So wrap the thing in a stub that you are in control over. You will need something that verifies your stub, but that's another topic. Reproducibility. Can we reproduce these things or not? Well, pure functions are easy, as I said. Otherwise, you probably have to write some kind of stub. So the best way I think you can do this is to create an interface and then have two implementations of it. Sometimes you can use a mock, but I find, yeah, mocks are great when you check interaction. Don't use them for creating stubs. You can do that with tools like Mockito. It works, but it's a bit painful. And if you have a stub, you can have prepared data sets, so all of a sudden parts of it is way easier. It also helps if you have a testable architecture. Not all architectures are testable. So, for example, Enterprise Java Beans, anyone working with them? No, not anymore. We used to. It was painful. Someone came up with Spring to solve the problem with dependency injection. So that's where we have Spring. That's from where we have Spring. It made life easier. But then we had configuration in XML instead. And I'm not convinced that that was a better place to be in. Then a clever guy called Alistair Coburn came up with a good idea that he calls hexagonal architecture. It's also known as ports and adapters. That he draws like this. So let's dive into this shortly. What's all about what this is about is that you have ports, and in this particular case you have driving ports on one side and then you have driven ports on the other side. And you can connect whatever you want to these ports. So a test or an external service is equal from that perspective. I'm running out of time here. Let's look at this one a little bit. We can see here that in the case of a weather service, for example, we can either attach a lot of tests to the ports, incoming ports, and do things, or something else. So everyone is created equal here. Tests are first-class citizen. You can do the same thing with databases, which is a very simple example, which I will not dwell too much into, because I am running out of time. The way forward here is, of course, test-driven development. And I say, of course, because if I'm an advocate of anything, that would be test-driven development. So I definitely recommend Outside In, the London School of Test-Driven Development, if you can. If you haven't read this book, Growing Object-Oriented Systems, Guided by Tests, by Steve Freeman, Nat Price, you want to read it. It's a good book. And this is seriously complicated, test-driven development, because you have to know about the tooling, you have to think ahead, too complicated things. Some developers are able to do it, not everyone. Yeah, and my conclusion today is that testability has to be a first-class citizen. If it isn't, then you have a problem. And the most broken systems are the one with really low or not too much testability. I'm working with one of them at the moment, and it's painful. And it's really easy to make silly mistakes if you don't test things first. I've made them myself, definitely. TDD solves some of these mistakes, not all of them. And a testable architecture helps a lot. And at the end, this is very much a mindset. And with that, my time is more than over. Sorry for running over, but thank you very much for attending. We will take questions outside, I guess, because next person is due in a couple of minutes. Thank you.